Previously, I did a video about using virtual tapes. And in that video, I commented that you wouldn't normally compile a program every time. Once you're out of the testing period, you wouldn't compile the program every time to run it. And so I thought I would show how I do that over here. As you can see my environment here. It's MVS using the TK4 package. I often do my work on the local system over here. Like I would keep my JCL and my COBOL programs and whatever I wanted to work on, and then I'd submit it from over here. So, but for this video, I thought I would just do most of it over here, except for the printer output. I find the printer output is better over on the on my local side. It prints out better and displays better. So anyway, as you can see, this is the environment, and so we're going to use the number 1 RFE. That's where we'll be going, and then we'll be number 3 utilities, and we'll be mostly using 3 and 4, mostly 4, but 3 at the beginning. Okay, I created this video to show how to create standalone executable programs on MVS. But I think if you want to follow this video exactly, you should create these three PDSs, partition data sets. If you want to follow it the way I did it, I keep my JCL in a separate partition data set, JCL PDS. This is the load lib. This is where I store the executable, the standalone executable, and WHB source is where I store the COBOL source, just the COBOL source, no JCL. And if you look over here, it's these bottom 3. These are all POs. Those are partition data sets. This top one is just a regular file. It's not a partition data set. So anyway, like I said, these 3 partition data sets are important for this to follow this video. So I will create them using this panel. Number 2 over here, data set create. So we're going to create these data sets from data set utilities. Number 2, create, delete, rename. So we choose number 2. I'm going to use a different prefix. In the video I'm using WHB, my initials, but I'm just to show you how to create them, I'm going to use TST for test. JCL.lib, and that beginning quote is important. If you don't put it, it will TK4 or whatever, however this is designed, will prefix your user ID in front of there. So, and I've just found other areas where I haven't put the leading quote, and it's caused me problems. So anyway, like I said, I'm going to steal some information from here. Valseer, C. Control V, paste. Now I need to come up here at the top and allocate it. A for allocate, new data set. Hit enter. And as you can see, data set is created. So now it remembers, in the session, it remembers those other parameters. So now is a good time just to create them all. JCL, SRC for source. Go up and type the allocate. It's already got those values we typed before. Data set created. The only thing left is the load lib. LOD. Enter. I forgot to put the A for allocate. Allocate. Just hit enter. And so that should be all three of them. We'll PF3 or F3. I'll go to 4. There's TST. So there's the three data sets, the three partition data sets, as you can tell by this organization. And the way, and obviously they're all empty right now. I'm going to copy a COBOL program over here into this source, so I don't need to type anything. But you will need to type some JCL. So here's the JCL lib. And the way you just do it is you just type edit, EDIT, and then the name of the JCL, whatever you want to call it, 01, and there you are. You got your screen where you can enter data / JCL 01. Obviously this isn't valid JCL. Ooh. If I PF3, there it is. There's the one member. If I look at it, it's what I typed. But like I said, I already got my JCL set up. I just went through that practice to show you how to create the partition data sets. I'm going to use these. My JCL in this library is already set up. The compile and go, the compile and link. This is the one that creates this standalone executable. This creates the PDSs, which we just did by the screen, but this is the JCL over here. This is pretty much equivalent to this. And then we got the run JCL. This JCL will run the program that was compiled and linked here. So anyway, that's pretty much what you need to know to get started to follow this. I'm going to be modifying the prime COB1 program that's provided with TK4. So it's not here right now, and you can see in my load library there's nothing in there either. So is we're going to go to, well, let's go back here 4. We're going to go to sys2 to show what we're going to be working with. .jcl, and we're going down here to prime COB1. This is provided with the TK4 system. And it's a great way to test the compiler. But I don't think you would normally keep your JCL within the program also. And normally you would never modify your original programs. You always want to keep your original. So this is what we're going to be working with. As you can see, all these / beginnings here are the JCL statements. So we're going to exit this, and we're going to go over to copy, move copy 3. And the way we do that is we're going to come down here. Since I've already done this, it remembers the things down here. So I'm going to take this. This is the data set, and you just hit enter, and so that's what we're getting. We're grabbing that prime COB1 that we just looked at out of JCL lib. And we'll come back up to the top and do the copy, move copy. So we'll copy, we'll hit enter, and it wants to know where it's going to. So we're coming down here, And we're going to go to WHB source PDS. You would just type that in, but since I've already done it, all I have to do is position my cursor here and hit enter. So if you can see here, 168 records copied. So now we'll go back to 4 DS list and WHB also. And we copied into WHB source PDS. So we'll look at that, and there it is. So what we're going to do here, we're going to edit this, and we're going to remove all the JCL. I'm just going to store the source, the COBOL source in my source library, and the JCL in the JCL library. So I'm taking all this out. The last slash there. Then we'll go to the bottom. Whoops. And remove the ending JCL. D99. So now all we have is the source. It's the COBOL source. And we've only modified it here in WHB. We haven't modified the original in sys2. So that's another benefit. And let's see, just for the fun of it, I'll come down here and add a statement in the procedure division. I'll probably edit this to compensate for my slow typing. So we're insert, $735. Whoops, make this capital. So I just added a display hi mom at the very beginning of this prime COB1 here. So now we've, as I said, we've removed all the JCL. So now we'll go to the JCL PDS where I keep my JCL. And I already showed you this one. I already just demoed the create PDS. So now I'm going to show the compile and go. And this does the same thing as the one in sys2. But as you can see down here, I tell it the input. Instead of including the input in the JCL, I tell it the input is in my source statement library, source PDS, and it's prime COB1. And then this execute COBUCG. This is a procedure. It's not an actual program, and it actually contains two steps: a COB step and a go step. This is the executable step. And this is where we feed it how many prime numbers we're going to generate. So now we got that. All we do is submit it. Like I said, the main thing is here's the source. So we're going to submit that. It was 1043, and as we can see down here, 1043. Like I said, I prefer to look at the output, and you'll see another reason why over here I spool my output to my local print queue, and then I've got this little job I run that parses that out. So here's the output of 1043. As you can see, two steps: the compiler and the loader. They both got return code 0. We'll page through this. There's the source. And here's the prime numbers. Here's the output. As you can see, there's the statement I added. Hi, Mom. And here's all the prime numbers. And as I said, this is another reason why it looks better over here, is because, as you can see, if you held this output on the 3270 side, it looks all jumbled because of this. I guess it can't handle this. As you can see, the column is 160. Well, that says 100. That's the beginning of, that's 161. So this is 160 characters. And evidently, the buffer over there, the screen buffer, can't print that out good without jumbling them all up. So this is another. It looks great over here. And as you can see, 999 found. So this is the same thing. This is the same results as we got with embedding as having the JCL and the program all together, but it's much simpler this way and cleaner, because now here's the fun of it, is we're going to compile and link. This is how you create a this is the JCL you need to create a standalone executable. Once again, you can see the sysin is my source library, prime code 1, but this time I'm telling it to put the executable in WHB load lib. So see, it's the same. It's much easier and cleaner this way, I think. So I'm going to submit this. I didn't have to pull the COBOL program out. So we'll submit this. And it's job 1044, which matches over here. We come over here. Here's the compile and link. You can see we got this is the linkage editor, both return code 0. If we go to the bottom, there's the source. It said prime code does not exist, but it has been added to data set. So now I'm going back over here, and we'll take a look at that. This time it should be in the WHB load lib. I showed you before that this was empty. So there it is. This is executable code. You can't edit. This is not something you edit. This is executable code ready to run. This is where I was saying you wouldn't normally test something and compile it every time you ran it. For a programmer would, while he's testing the program, it's great, but once you get it working, you would create an executable. So now that I showed you that, go back up here to the JCL lib, and I got this. Here's the JCL. Run it. As you can see, this time I think I said 999 before. This time I'm going to generate the maximum amount of prime numbers, 32,767. And this time I tell it, I use a job lib, or I could have used a step lib, but I said I tell it where it's located at. And this time I use rather than just leave it blank or type proc equal. This time I'm executing a program, not the procedure. I'm executing this program out of this library right above it. And here's the input. So we come up here, sub. It's only a character, whatever. 1046, 1046. Come over here. Let's close this. Parse it out. There it is, 1046. Run it. Let's go back up here. Return code 0. We'll go down, and there they are. That's hi mom. But this time it generated 32,767 up to 32,767 prime numbers. So that's how you do it. That's how you create a standalone executable.